One of the things I wanted to point out to you in greater detail, if you go back to the example and you look at the pivotal conditional branch where we could either, we figured out the password and we got success, or we didn't have success in our test program, how do we know that that comparison was actually a signed comparison? Well, it's very easy actually in x86. If there's an above or below, we're talking about an unsigned comparison. So if we had seen a jump above or jump below, those different conditional jumps, and they tend to use the carry flag, where if we saw a greater or less than, we knew that we were dealing with a signed comparison, and those use either the sign, the zero, or the overflow flag. And since we saw a jump instruction that used the zero flag, we knew that we were actually dealing with a signed comparison. That's exactly how it did that. And that's exactly how those tools, by the way, can go from assembly all the way back to a decompiler and try to represent the code to you in C. They use all of those hints throughout to create the actual code. And that's what we have to do kind of mentally and manually if we don't have a decompiler. All right, so it's quiz time, and it's time to see if we've learned anything about assembly yet, or time to learn more. And what's interesting about these actually are quizzes that I received a long time ago when I interviewed for a job one time. They wanted to know if I knew anything about low-level assembly and things, and these are the quizzes that they gave me. So the interviewer asked me, can you tell me what higher-level C API this assembly represents, and what else can you tell me about it? And what he was looking for is a conversation along the lines of, well, first of all, you see the underscore ASM in the curly brackets, which means that this is embedded assembly within a greater C program. Secondly, you also see variables like the word buff, so that, again, we know that this is part of some greater C program where variables are defined outside of the scope of this assembly. Next, all you have to do is break this down piece by piece to figure out what it's actually doing, and then equate that to a high-level C API. We see that 100 is moved to ECX. And that's the count register in many cases. We see that EAX is cleared and holds the value 0. EDI, the destination register, holds a reference to buffer, so that's where we're going to put stuff. CLD clears the direction flag so that we know we copy from the beginning of that buffer to the end. And then we see a rep, store string byte, which we haven't talked about the rep yet, so now's our chance. The rep basically does something ECX times, so we're going to store a byte, and that byte is the byte held in EAX into the destination 100 times. So what are we doing if we're putting 100 nulls into a buffer? Probably we're doing something like memset buff 100, and that's exactly what they were looking for as the answer to this quiz. And you could do this all day long, which we won't, but let's do one more, and you can make these more and more difficult and longer as you go to see if we can figure out again what's the higher level API. So we move 100 into ECX, we clear EX, we move a source into EDI, and we rep not equals scan string byte. So basically we're looking in this source until we find EAX, which is null, until we find a null. So why do we search for a null? Well, string length actually does that. It wants to find the first null in a string, and that's how it knows how big a string is. Next, we move the source into ECX. We subtract ECX from EDI. That gives us a number, basically the string length, and we put that into ECX. So now we have the length of the original string in our count. We move source into ESI again, and then we LEA buff into EDI, the destination, and we rep move string byte. So we're going to move whatever's in source to destination ECX times. So we basically got a mem copy from source to dest, and we're going to do it of the size of Sterling, which means that this copy is not a safe operation because we don't know, according to this anyway, how big destination is. So destination better be at least the size of source, and if source is something that's dynamic or different each time, this could be a real problem. Basically, this could be an unbounded string copy, which could give us a buffer overflow.